In this video, I will show you how to solve distance, rate, and time problems. From this topic onwards, we will be using formulas to solve some problems. So for this lesson, we will be using the formula distance is equal to the rate times the time. We know the relationships between distance, the rate, and the time. For example, your car is traveling at 50 kilometers per hour. So it means the car can travel a distance of 50 in 1 hour. Or how far will the car travel if it travels for 2 hours? Okay, so 50 per hour is the rate times the time, which is 2 hours. It will cover a distance of 100 kilometers. So this is the formula. Distance is equal to the rate times the time, or D is equal to RT. It can also be D is equal to T times R, because interchanging the two will not matter. From this formula, we can get several formulas. Example, if we are looking for the rate, given the distance and the time, we will just divide this by the time. So we will have here the rate, and the left is distance over the time. So we can derive the formula. We can also derive the other formula, the formula for the time, by dividing both sides by the rate. So eliminating R, we have T is equal to D over the R. For you to remember all the formulas, even without deriving, we can put them in this triangle. So we can make a triangle like this. So we will put here D and the rate and the time. Okay, how are we going to use this formula? So if we are looking for the distance, we will just cover letter D, because that is what we are looking for. What remains is R and T. So this means multiplication. So we will multiply the given rate and time. So the formula for the distance is rate times the time, or D times TR. So it's up to you to choose which one. If you can easily remember D is equal to RT, it's okay. Maybe we can use this DTR because it can be somewhat related to the time, like in DTR that we accomplish. Okay, daily time record. If we are looking for the rate, given the distance and the time, we can cover the R, and what remains is D over the time. So the formula is R is D over the time. That is for the rate. And if we are looking for the time, and given R the distance and the rate, we will just cover T. What remains is D over R. So our formula for the time is distance over R. Those are the formulas that are used in distance, rate, and time problems. But in this video, in our lesson, we will solve distance, rate, and time problems involving two different moving objects. Okay, let's see the difference by trying some of the problems. In this course, we will not just do the simple finding the unknown or the missing quantity in distance, rate, and time problems. Instead, we will be solving problems that involve two moving objects. These two moving objects might have same or different speeds or rate, different or same time, and even the distances. Since we are dealing with two different objects, we will take into consideration the directions that they are traveling to. So our problems in distance, rate, and time, or also known as the uniform motion problems, we will have three different setups. First is the same direction, where object A and object B goes to the same direction, either both traveling to the right or to the left or northbound or southbound. This is the first instance. Another instance is that the two objects are traveling in opposite directions. If A is going right, object B is going left. That is the second instance. While the third is called the round trip problems. Round trip means from one place you go to another place, point A, from point A to point B, then you go back from B to A. That is called the round trip problem. So if you will see, the illustrations in 2 and 3 seems the same. So we will change this. We can either write this like this one, facing each other. So from point, since we use A and B as objects, we can use from point 1 to point, and the other one is from point 2, and they are facing each other.